Okay, welcome everyone. We are officially on to our first modality. So we're gonna jump ahead in the book and talk about electrotherapy first. The reason I do this is I really like to, having just talked about pain theories, be able to then go into talking about e-stim, since the main use of electrical stimulation is for pain relief. So what we need to do as we approach every modality is understand the science behind that modality. So there's a lot of physics in modalities actually. So with electrical stimulation, we're going to spend some time reviewing the science of electricity. So you should have already watched a couple of the like quick physics videos that I've posted. If you need more of those reviews, there's some more optional ones there as well. But basically, you need to have a good foundational understanding of what electricity is, how a current flows, what affects that current flow, so resistance and voltage and so on, and then what and how do we create a circuit, okay? So make sure you understand those components. I'll talk a little bit about some of those as we go through in this PowerPoint as well, so maybe you'll get some clarification from the original videos. But we're mainly going to focus in my presentations on how it connects to the body. So when we talk about electromagnetic modalities, we're mainly talking about electrical stimulation. We'll also talk about diathermy when we get to talking about heat. That's also an electromagnetic modality. And so the background of talking about these modalities is understanding electromagnetic radiation and the fact that electromagnetic radiation is a form of energy that travels through space. Okay, all matter produces some radiant energy, and that's usually in the form of heat. So remember also that energy is neither created nor destroyed, and so it's converted. And so when we apply energy, and this goes for really all of our modalities, whether we apply manual, mechanical energy, chemical energy, sound energy, electrical energy, when we apply energy to the body, it transfers and converts into various forms of energy. And one of the byproducts can be heat, or it could be kinetic energy, cellular activity, things like that. And so we're always talking about that conversion of energy, and when that conversion happens in the body, those are the results we're trying to target. Electromagnetic radiation can be produced by chemical or electrical forces. It always travels within a straight line, and when it travels and hits a medium, it's either absorbed, so absorbed by the matter, it's reflected, it's refracted. So reflected would be completely straight off of the surface. Refracted would be that it comes off at an angle, or it can be transmitted through. And usually it's a combination of all of these, especially when we talk about electromagnetic. Usually we'll have some of the energy absorbed, some will be transmitted, some will be reflected off. And so the goal is to get some sort of physiological response. And when we're talking about e-stim, these are some of the main ones we're talking about. Muscle contraction, sensory modulation, so our pain relief, inhibiting muscle spasms, even fracture healing, wound healing, many things like that. So thinking about these electromagnetic waves, so particles that, or the wave energy that we have for electrical, we have two concepts that are related to each other. We have the wavelength, which is the distance between the peak of one wave to the peak of the next wave. And then it's frequency, which is the number of waves that occur in 1 second. And we tend to call that rate. So it's either measured as hertz or cycles per second or pulses per second. And we'll use various terminology as we go through the modalities talking about frequency. All forms of energy, electromagnetic radiation, have a specific wavelength and a specific frequency. And that is because all electrical energy travels at the speed of light. So velocity stays constant, and that's 3 times 10 to the 8th meters per second. And so what that means is we create an inverse relationship between wavelength and frequency. So if velocity is always held constant, then as wavelength increases, frequency is going to have to decrease, or vice versa. When wavelength decreases, frequency is going to have to increase. And so as we start talking about designing the waves, we're going to talk about focusing on frequency, but know that by altering frequency, we alter wavelength because of the constant velocity. So here's a couple terms that you need to be comfortable with moving forward, because we're going to use them. So again, hopefully you've watched the videos already with some of the background of this, but amperage, which is represented by I, is really talking about current flow. So it's the rate at which electrical currents flow. And so an ampere is the unit that we use to measure current flow, or amperage. So it's equal to the rate of flow of one coulomb per second. It's you know, using, again, we'll see down here, Ohm's law of that current is equal to the voltage divided by the resistance. So then we have charge, which is the charge of the current. And so a coulomb, or Q, is the basic unit of charge. It has a net positive or negative electrical charge based on electrons. Coulomb's law is that like charges repel and unlike charges attract. So when we start talking about creating a battery and creating a central flow, like charges are going to repel each other. And so we'll talk about that a lot more when we talk about iontophoresis as well. A joule is the basic unit of work. So 1 joule is the work that it takes to move 1 coulomb. The ohm, that should be an R, not a V. So this should be resistance, which is R. It's the unit of electrical resistance. So R is equal to, the resistance is equal to the voltage over the current, or the amperage. So Ohm's law is that current is directly proportional to the voltage and inversely proportional to the resistance. So you saw that in the video, and we'll talk about that more coming up. And then the voltage is the potential for the electron flow to occur. So in the video, they actually do a really good job talking about the height of the waterfall and how that would be the equivalent of potential energy in this case. So the potential for that current to flow based on the charges at the negative pole, or the cathode, and the charges at the positive pole, or the anode. And then watt is a unit of the electrical power. So it has to do with the voltage as well as the current in there.